Drilling fluids are used to perform the following 6 functions: to stabilize the wellbore while controlling subsurface pressure, to suspend drilled particles and transport them to the surface, to cool and lubricate the bit and drill string, to assist in formation evaluation while minimizing formation damage, to assist in supporting the suspended drill string, and to transmit hydraulic horsepower to the bit. Let's look at each of these functions individually. The normal fluid pressure gradient of the Earth is about 0.465 psi per foot of depth, which is equivalent to a column of fluid weighing about 8.9 pounds per gallon. In many drilling areas, the weight of water plus accumulated drilling solids is sufficient to balance this gradient and thus prevent fluid flow into the wellbore from permeable formations. However, there are areas where abnormally high pressures require an increase in the density of the drilling fluid. In such cases, the drilling fluid will be weighted up with a high specific gravity additive. Typically, the column of drilling fluid exerts a slightly higher pressure than that within the drilled formations, a condition which results in some degree of fluid flow into permeable rocks. The drilling fluid must be designed to form a filter cake of solid particles against the wellbore wall, preventing significant fluid loss into the formation and thus stabilizing the hole. The addition of specially formulated natural clays to the drilling fluid normally provides this capability. These same clays also improve the drilling fluid's ability to transport the drilled rock cuttings to the surface, where they can be screened out and sampled for geological information. The fluid's viscosity permits it to carry these particles in suspension, and the clay increases the viscosity of the fluid. The clay also gives the fluid gel strength, a property which causes the mud to stiffen or gel when pumping stops, but allows it to liquefy again when pumping resumes. This property keeps the suspended cuttings from falling to the bottom of the hole when circulation is halted. With subsurface temperatures in the hundreds of degrees Fahrenheit and enormous pressures being applied at the drill bit's face, the need to cool the rotating surfaces of the bit's components becomes important. The 4th function of the drilling fluid is to aid in the collection of geological information. The most obvious manner in which this is accomplished is by the transport of cuttings to the surface. By calculating the depth at which these cuttings were drilled, a lithological log of the hole can be developed. Coupled with detection of formation fluids in the returning mud, this information is the first glimpse of the subsurface available to the geologist. But the drilling fluid also provides important assistance to the logging of the drilled hole by permitting the shallow invasion of a known salinity filtrate